Section 5.5, solving quadratics by using square roots. Also, you might think of it as inverse operations. This should be a fairly easy topic. There's only going to be two different types of problems that you're going to be responsible for. The two problems you see right here, they're not those types of problems. These are just warm-up types of problems or leading types of problems that get you into what you should be doing. So, this would be a linear equation. It is not quadratic because it doesn't have a second degree here. See, if it had that, it would be quadratic, and that'd be the type of problem we would solve in this unit, but that's not what is going on here. So, it's just linear, and we would use inverse operations. We'd look at what's happening to the x, and we'd undo that. So, we would see that the 2 is being added, so we'd subtract it from both sides. Then we would see that the 3 is multiplying the x, and we want to undo that. Typically, you're going to use order of operations or inverse order of operations to unravel the puzzle to solve an algebra problem. As you can see, I added or subtracted first and multiplied or divide. There are exceptions to that rule, but typically that's what we're going to do. Okay, so here's another inverse operation we're going to use. We've got a square. The inverse operation of a square is a square root. Hopefully you know that the square root of 100 is 10, but I have to warn you, and this is going to be very important for this section, that when you take a square root to cancel out a square, you've got to put the plus or minus. I didn't really leave myself enough room for that, because I could say, hey guys, I'm thinking of a number. If you square my number, you get 100. And if everybody in the room guesses 10, I'd just say, nope, you're all wrong. I was thinking of negative 10, because negative 10 times negative 10 is 100. So there are two solutions to this. So, once again, whenever you take a square root to cancel out a square, you put plus or minus. So our answers are plus or minus 10. So that was a one-step problem, but with just a rule to remember. So here we go. These are the two types of problems we're going to have to do. I've got 3x squared plus 5 equals 41. Just going to go through these problems. I'll explain why they work with this inverse operations in a bit, actually just after I get through example 2, and then I'll give you some more to practice on. So we're going to subtract 5 from both sides. So I've got 3x squared. That cancels out because it's plus 0. And then I have 41 minus 5, so we got 36. All right, now, two more things to do. It's unlike that linear equation on the previous page. It didn't have a square. This one does. So I've got a 3 that's multiplying it. I've got a 2 that's a power. The order of operations is PEMDAS. We've talked about it before. It's been quite a while. P is really more like G grouping symbols, and we actually don't see that here. We have exponents, we have multiplication, the 3 is multiplying, we have addition. So when we undo these, we're going to typically undo them in reverse order. So we subtracted to cancel out the addition. Now we're going to divide to cancel out the multiplication. So we have x squared is equal to 12. Okay, now we're on the last one. We have an exponent, which is the power of 2, and we're going to cancel that out with its inverse operation, which is take the square root. When I take the square root to cancel out a square, I've got to put plus or minus. This square root cancels out that square, and I get x, and then I have plus or minus the square root of 12. And for now, that's going to be fine. In the next unit, we're going to review, or maybe for some of you cover for the first time, simplifying this radical, but for now we're leaving it. That'll save us some time on this video. Alright, next one. Following this reverse order of operations, I've got division and I've got a square root. Then I'm going to do the subtraction. Why? Because that's actually inside the parentheses, so I have to wait till last on that one. So divide both sides by 3, and I get x plus 2 squared is equal to 4. Take the square root of both sides, put the plus or minus because you took a square root to cancel out a square, and now we have x plus 2 equals, well, the square root of 4, unlike the square root of 12, should be something you should be able to do. The square root of 4 is 2, so it's plus or minus 2. Now there are two answers on this side, and I haven't even finished solving it yet. So what I want you to do is I want you to break this up into the two situations. It's kind of like our absolute value, but this should actually be a little bit clearer. Most people have no problems with this. So I'm going to do the x plus 2 equals 2 over here, and on this side I'm going to do x plus 2 equals negative 2. And then both cases, just subtract 2 from both sides. And here I get x equals 0. And here I get x equals negative 4. You could actually check that. You could check any of these, and they're usually not too hard if you're clever about where to check it. Original spot is perfectly fine. Subtract negative 4 and positive 2, or add negative 4 and positive 2, and I'll get negative 2. Square a negative 2, I get a positive 4. 3 times 4 is 12, so that works. And the 0 plus 2 is 2. Square the 2, I get 4. 3 times 4, I get 12. They both work. X equals 0. X equals negative 4. Alright, we're cruising along. Okay, so maybe I should back up a little bit here. We're looking at both types of problems. Last page had both types of problems. This page has both types of problems. So what are the two types? The top one is something like ax squared plus bx plus c equals 0, standard quadratic form. But there's a couple of exceptions, but you're going to have to be able to identify them. I don't have equals 0, but I can make that happen. Add 2. Add 2 to both sides to balance it out. X squared over 25 minus 4 equals 0. And now you see that it's in this form, but it's missing the bx. Let's go back a page. This was also missing the b term. I've got a second degree term, a is 3. I've got a c term. I never really did solve for the constant because I didn't subtract 41 from both sides. I subtracted 5 and got 36. If I did subtract the 41, c would have been negative 36. So the first type is, get rid of that, ax squared plus c equals 0, and that can be solved with inverse operations. The other type isn't really in that form. It looks an awful lot like vertex form. You have one like that on the previous page as well. You see you've got some quantity that is squared, and you isolate that quantity and then take the square root. Well, that happens here too. You want to isolate this quantity, then take the square root. For instance, we're going to add 12 to both sides, and we get x plus 2 quantity squared is equal to 64. Now cancel out the square because the parentheses is going to happen last. We're going to get x plus 2 equals, take the square root of 64, but I canceled out a square, that one, with the square root. This square root here on this side, it's balancing the equation. Here, I'll actually put that square root in here and there. The plus or minus happens. That square root cancels out that square. So now it looks like this. I've got my two different outcomes. Either I've got positive square root of 64 or negative square root of 64. By the way, that's 8, but you probably knew that. So I've got x plus 2 equals 8. I've also got x plus 2 is equal to negative 8. And subtract 2 from both sides, I get x equals 6. Subtract 2 from both sides, I get x equals negative 10. Alright, well I didn't finish this one. I'm looking at it the way I have it right now, and I kind of already see an answer. I'm going to go ahead and finish with what I see, but then I'm going to erase everything and back it up. I'm looking at a difference of squares here. That does not always happen with problems of this type, where you don't have b. For instance, on this side, did I have a difference of squares? No, because 3 was not a perfect square. So, how is this a perfect square? Well, every square is a perfect square, and 25 is a perfect square. So, I'm looking at x over 5. Square root of x squared is x, square root of 25 is 5, and then square root of 4 is 2. So, here are my two factors. And then I use a zero product rule and solve those. But I'm not going to finish that. At least not right now. What I'm going to do is back this up. I'm going to switch to blue. I'm going to erase, actually nothing. I'm not going to erase anything. But what I'm going to do is do it like I did example 1, which is just start using inverse operations. So instead of getting in a standard form and factoring, I'm going to add 6 to both sides. So it's really going to start off like this. I'll show you that either way is going to work in this particular case. So I add 6 to both sides and I will get 4. Then I could multiply both sides by 25. When I multiply this side by 25, 25 25ths becomes 1. 1 times x squared is x squared. And on this side, 4 times 25 is 100. I could have taken the square root at this point because both of those are perfect squares. Well, I'm going to take the square root now. X equals plus or minus the square root of 100, and the square root of 100 is 10. So x equals plus or minus 10. I'm done. I have both my answers, unlike this one down here where I had another step and had to isolate the two cases and solve each, because there's nothing over here with the x. So plus or minus 10, perfect. So how would this turn out to be plus or minus 10? Well, you'd use a zero product rule, and you'd set each one of those factors equal to 0. I'll only do 1. I'll add 2 to both sides, and then multiply by 5. And the other factor, if I set it equal to 0, that'd give me my negative 10. So x equals plus or minus 10. Alright, that might have been confusing since I saw two different ways to solve it. And this is, the factoring way is not the way I'm trying to explain in this video, but, if you saw it and it could have been done that way, you're more than welcome to do that. Okay. What you should do is pause the video, actually try this one, then come back to the video and see how you did. Okay, here's what I got. I added 6 to both sides, got 12. In this step, multiplied both sides by 3. 1/3 times 3 is 1. So 1 times a quantity. It's as if it canceled out. On the other side, balance it out. We multiplied by 3. 12 times 3 is 36. This is the step where I took the square root of both sides. When you take the square root to cancel out a square, you got to put plus or minus. That square root cancels out that square. The square root of 36, a perfect square, so it's 6. And then I got my two cases. Either it was 6 or it was negative 6. Solve each individually. We got x equals 4 and x equals negative 8. And that's it. Our two cases for solving quadratics using inverse operations. It doesn't happen a lot, but if you see that there's no b term, or if it looks like it's in vertex form where it's got a quantity squared, no other x in it, then you can solve with inverse operations.